Hello everyone, let's continue building a dungeon crawler. So I'll set a timer for 25 minutes, that's 1 Pomodoro, and the goal for this one will be to write proper code to move our player around. So timer started, let's look at what we have first. So we have a viewpoint, we can move forward and backwards, and we can go out of bounds, we can go through walls. So far from done, but we have a thing where we can influence the world by interacting with it. So the code we use to do that is a bit of throwaway code, so I'm going to delete a lot of it. That'll be the first step. So I'm going to take out the updating of the player's world position. I'm taking out all this stuff from the player position, from the world. I guess we can keep the world class. We're probably calling this at some places, so we can get rid of these buttons. Now all we have is more or less our viewpoint, and that's a nice clean shade, because I want to start thinking about the kinds of behavior we want to get in the game first. We created a couple of small documents to keep track of our tech debt, our nodes, and our backlog, and for our third Pomodoro, that's this one, the focus will be moving around. So let's start working on moving forward first. And that's in line with the backlog that starts with player movement, and then making sure that we can call that movement from the user interface. So this means that we can start writing a test, and I'll create a test suite for player movement should and the first test will be move forward when we instruct the player to move forward. So we'll create a function called move player forward, and that means that we can now start thinking about our API. And here we can do a couple of things. We could say we have a player, and then issue a command like player move forward, and then expect player.position to be something like 0 and 1. We could do this, or we could introduce a world, but I don't think we really need a world yet at this time. So let's go for this approach. So I'll open a second window, and here I can create a new file. Player.swift, and this will be a class player, and well, let's see, so the player should have a position, it's probably something like this, and it should have a move function, And this also means that we need a coordinate. So this will be an X and a Y coordinate. And for now, let's do something like this. And we need a direction. Let's see, I will have a forward case. And now I think at least this code should compile. Oh, and the position should be equatable. So a coordinate needs to conform to equatable, which it can automatically synthesize. So let's see, do we move? Okay, so this builds. And this fails, but let's fix it by setting our position to 0 and 1. Okay, now let's refactor this code a bit, and the first thing we can do is move the coordinates into a separate file. And the direction we can place in its own file as well. So we save this one, and our test should still pass. Actually, that's not a bad moment to do a quick commit. So we added a test. Just call this, I call it like this. And now we have this committed. So, but of course this is not a good implementation because we're hard setting a position. So I think the easiest test to solve this is to say move forward twice. Should get to coordinate 0, 2 when it moves forward twice. So now I have new test, and this fails. Ideally, I would be able to say, let's see, we have our position. Maybe this is enough to at least get it passing. Okay, so it passes. You can do a quick commit. And then let's refactor this code a bit. So let's see, so we have, what I think would be nice is if we could write something like position plus a direction. So that means that we, in our coordinate, we need to add a static. Is this a prefix? I think so. Function. I might need to look this up a bit. And on the right hand side, we have our coordinates, and we have a direction, and then we return. Let's just look it up very quickly. And I'm not interested. Okay, this is a minus compound assignment. This is the one. Okay, cool. So it's just a static function plus equals, and then the one that you're changing and what you're adding to it. So we could say coordinate dot y plus 1, meaning that these now do become changeable. So if I understand correctly, we should now be able to say plus or minus the direction. Okay, so this passes. Of course, this isn't right yet because we're hard coding, changing just the y coordinate, and we're not even taking the direction into account, but at least we now have our API working as expected. So the next step would be to commit this one. So what would be a nice next test? Well, what we could do is we could say, what if we parameterize this test and say, if I pass in a direction of forward, then I expect the resulting coordinates to be 0, 1. And then we can pass in a test case here that is a tuple that contains a direction and an expected position that is a coordinate. So this will be a direction. And then we can say we pass in the test case dot direction, and we check if the position becomes our test case dot expected position. So let's try build and running this test. So this passes. Let's try a different direction. So let's say I go backwards, then yeah, I think that's a nice word. You could also choose just back, but I think backwards will be okay here. So let's take a direction. So this now compiles, but the test fails. So the easiest way of solving this will probably be to take our coordinates and say, if our direction equals forward, we do this, and otherwise we do that. Okay, so test passes. Let's quit it real quickly. Also, let's rename this one now. Get to the expected coordinates, when movement direction, when it moves in a specified direction. Okay, so then I can take this one and commit it. And now we can refactor this code. So this if else is of course not the right way of doing this. So what if I said that direction has two coordinates, and this returns a coordinate. So I could say switch on self, and the case, well, thank you very much. So Apple Intelligence, but that wasn't really what I was going for. Then we could do something like coordinate dot y plus equals direction to coordinate y, and later on we could do the same thing for the x coordinate. I think we can even go one step further if we say, what if we have a static function that takes a coordinate and another coordinate. So we have a left hand side and a right hand side. Then we say left hand side dot y. We add the right hand side dot y. And now we should be able to just say okay, I'm going to commit this one. Let's see, so we refactored our code to move forward and backwards in a more elegant fashion. What was the change we did? Why describe this? Conversion between directions and coordinates, so they can be added together. Okay. Let's continue. So, of course, we also want to move to the left. That one doesn't exist yet. I'll also add the right at least in here, because it's like more of the same. So to the left would be -1 and 0. So I go to the left. And this one fails for the last case. But that is solved if we also add the x coordinates here. And now this one passes. So I could add that one. And we can do the same for right, but this one already works. Now I've already feel quite confident that I already solved the situation that you can also move left twice or right twice or backward twice, because we fixed both directions as well as how often you do it. If you want, you could add an additional test just to see if this works as expected. So let's see, what if we go stays in the same position when you move forward first, then right, then back, and finally to the left. Let's see, so go forward, right, back and left. So we're moving in a circle. So we go forward, go right, we go back, and we go to the left. We should end up where we started. And this works. If you want to be really careful, maybe you don't trust this completely, so maybe you want to go forward and go right a couple of times. Let's see, so then I'll end up at 1 and 4 a couple of times. And personally, I don't think this test is really necessary, because it was already covered enough by just these two cases. So I am going to remove this one, but I'll for now leave the circle one. That might help us later on. So we move right and move in a circle. Is there anything that we can do in terms of improving our code? I don't really think so. It's just really simple. It's really simple code. So I think this will be enough for now. So we have covered moving forwards, backwards, left and right, and we have moving in a direction multiple times, and we refactored the code to be nice and clean. And then we can start thinking about what do you want to do for the next one. Well, either we continue with movement. We could say, let's rotate around. That could be cool. Or we could make you not jump into walls. Now I'll say, let's do rotation first. So that's sort of the plan. And this is interesting because what we consider forward and backwards will depend on our looking position. Let's see, so in terms of our tech depth, well, we got rid of this code. We just got rid of all the non-test driven code. So that's that one's done. We have a node, we have a backlog, we have moving in all cardinal directions. I'll put a thing around it, and the next one is indeed rotating around. Let's see, there is half a minute left on our Pomodoro. That's, I think, a good time to just git push. Oh, oops. We also updated our documents. We pushed. And that's it for this episode. I'll see you at the next Pomodoro. Thanks for watching and have a good day.